3D printing is building up from the bottom, layer by layer, stacking of materials.
It's really a bottom up and a left to right and a forward and back kind of technology.
It can make an experience happen. It can make something more than just an object.
Our whole focus is on making 3D printing technology do what can't be done.
Build something small, build it really well, and go put it out on the market, go test it, go ride it.
It could be education, or it could be prototyping, or it could be just general exploration of ideas.
It's not the technology, it's the ideas that feed into them. That's what matters.
We're going to try and bring multi-materials into the desktop 3D printing space. You know, the ability to explore carbon fiber, metal, wood, and to start to get a sense for people what they can start to make for those particular applications.
These are some of the earlier test prints that we did on the silicone printer, and we're really just looking into combinations of materials, really trying to find the right combination of fabric and silicone. So right off the bat, we had all of this technical fabric, and we found that fabrics with natural fibers in them, like hemp fabrics or something that's a cotton blend, really grabs the silicone kind of because of the micro porosity of the fibers that are inside of the fabric. So I printed a channel of the silicone and then bent the copper wire into it and then printed a final pass over it. So there's all of this kind of hidden rigidity inside of the fabric that you can get out of it.
And we're essentially developing a new wearable air quality monitor. What this will do is allow people to detect the levels of pollution that they're exposed to as they go about their day, wherever they are. And then they can essentially change their activities and where they go and what they do with this additional data feed. And this will be important for people with chronic lung disease, especially.
You know, the freedom of complexity that additive manufacturing or 3D printing allows for the iterative space, the iterative design process, it's really incredible, and it's well matched. It's an appropriate technology for that space.
So what we're aiming to do is allow our customers to de-risk their assets going into clinical trials. In other words, they feel more confident about the response of the drug, as well as allow the customer to test drugs that they may not have otherwise been able to even test. So what we can do is use 3D printed human tissue models for developing new drugs. And what we're trying to do is make more advanced models that better replicate the human tissue physiology. Aspect Biosystems is unique from the technology perspective. So we've taken a combination of microfluidics technology and combined that with 3D printing technology to make a completely new type of 3D printer that we call lab on a printer. We can perform certain laboratory functions within the print head itself before the bio ink, in this case, is extruded. As the technology advances further, we will get to the point where we can print off full organs. So I think within probably 10, 15 years, maybe even less, we'll be seeing that kind of thing come out.
I'm excited about when home printers get robust enough to print a usable part, something I can put in my ski bindings to replace something or try something new and go ski it.